Alright, in this session we're going to talk about how to set up a milling file inside Mastercam. We're going to learn about facing, rough milling the outside of this part. Now I know it's a very simple shape, but whatever you learn on this simple shape will also apply on more complex shapes. So we're going to learn how to control depth of cut, do rough passes and finish passes, and I'll show you how to set up your stock on the outside, and then also how to control your lead in and lead out passes. So let's start by opening up a new file. Alright, so we have opened up a new file, and the first thing we need to do is make sure that all the views are set to top. If they're not, click on G view, click top, open up planes and click top. Alright, then make sure it says 2D. You can toggle this from 2D to 3D. Make sure it says 2D, and in the Z field right here, make sure we are at 0. Select yourself a color that you want to draw with, and then let's get started with our basic shape. So while holding the Alt key down and the center button, we're going to pan our crosshair to the upper left hand corner of the screen. Alright, then we're going to select create rectangular shapes, and we're going to enter 4 inches for the length and 3 inches for the width. We're not going to select the radius. The shape is going to be rectangular, and we're going to anchor to the top left corner of the rectangle, and then we're going to let it snap to our crosshair and left click and click OK. Then we're going to right click. We're going to click on fit, right click again, and unzoom a couple of times, and now it should be nice and centered up on your screen. Okay, then hold your center button down and roll it to where you get somewhat of an isometric view. Okay, because we're going to translate this rectangular down 1 inch. Alright, so we're going to click on X-Form Translate. Then we're going to pull down this little menu here and select chain. We're just going to highlight one of those legs, and because we were set to chain, it will grab the whole rectangle, and then we'll select End Selection. Then we're going to join, and we're going to translate a -1 inch, and we're going to click OK. Now again, red is the original, the purple is the resulting color of your translation. So then we click on Clear Colors, and we're back to our system color. Alright, so the next thing we're going to do is select a machine type. So from the menu here at the top, left click on machine type, then wand over mill, and instead of picking default, let's go to manage list. On the left side you should see a few of your mill post processors, and then let's select a file that we're going to use most often. In this case we're going to use a mill 3-axis vertical machining center, and we're going to click on add and then click OK. So now if we click on machine type, wand over mill, you can see that becomes one of our mills that we can grab real quick. So when you click on that, you can see right here in the toolpaths operation menu, you can see the machine group showing the 3-axis vertical machining center. Alright, so the next thing we're going to do is click on this icon that says top. So we're looking at the top view. Then in this operations manager, click on the plus sign next to properties, and then select the stock setup. Make sure that shape is set to a rectangular. Put a check mark in display. Left click on bounding box. Make sure we have a check mark in stock and just click OK. So here you can see the basic dimensions of our rectangle. We have 3 inches in Y and 4 inches in X. Now we're going to add stock to that. So we click in the box right next to 3. We enter plus 0.5. Enter. Now you can see that made it 3.5. So it added a 1/4 inch on each side of the Y. We're going to do the same thing with X. We're going to say plus 0.5. Enter. So it makes it 4.5. Now, even though our part is 1 inch thick, we're going to start out with 1 inch 375 stock, so that we have about almost 3/8 of an inch to hold on to. Okay. Then right here where it says stock origin, in the Z, we're going to shift the stock up 50 thousandths because that is the excess material we're going to be taking off with our facing operation. Then we click OK. So you can see the stock outlined around your part. You can see that it automatically adjusted the excess material evenly all around the part. So again, if we rotate our part, you can see we have our 1 inch thick part in our 1 3/8 thick stock. Okay. Now, if I click on front view and I zoom in, you can also see that I shifted 50 thousandths so that we have actually stock on top of the part that want to be facing off. So back to isometric view, right click, fit, and then roll your center button out in your back to where the part is in the middle of your screen. Alright, so now to turn off that raw material, you left click on the stock setup and you take the check mark out of display and then click OK, and now it is gone. Or you can change it from wireframe to solid. Okay, and click OK, and it gives you a transparent view of the raw material. Alright, so for now we're going to go back to stock setup, wireframe, and being able to see the raw material will help us as we're creating our tool paths to make sure that our approach of our tool is not going to crash into the solid material. Alright, so the first thing we're going to do is face the top. So we're going to right click next to this red arrow, I'm going to wand over Mill Toolpaths and then select Face. Then go ahead and enter a name or just click OK. Then it says here select OK to use defined stock or select the chain. Now we can either select the chain at the top of our part or just let the system look at the stock that we created and let it do the work for you. So we just click OK. Then click on Tool, select the Library tool. It should automatically show you all the face mills. If it doesn't, click on Filter, make sure that face mill is highlighted, and then click OK and you should see this. Then select 2-inch face mill, click OK. Now that is tool number 316, so we're going to edit. So right click, edit, and then we're going to make that tool number 1. Now notice the diameter says 2 inches and the taper angle should say 45 degrees. Go ahead and let all these other numbers default out and we'll click OK. Alright, so at the top it says tool diameter 2 inch, corner radius 0, tool name 2-inch face mill, and then tool number 1. Then we're going to manually enter the surface feet per minute and we're going to put that at 500. Click enter. Then feet per tooth is going to be 10 thousandths. Hit enter. That puts us at 19.1 inches per minute. And the plunge feed rate, that is the feed rate that the tool will come down with, is going to be 30 inches a minute. Then we'll put a check mark in a force tool change, and in the comment section we're just going to enter face. Then from the cut parameters, the style is going to be one way. Now you have a pull down menu, you can zigzag, one pass, and dynamic. We're going to select one way. Make sure tip comp is at the top. Roll cutters around corner, set it sharp, it's okay. And under stock to leave on floors, make sure you make that a 0. Now over here at cross overlap, that is how much the tool will overlap the side of the part as it's going across. Then the along overlap is 2.2, approach distance is 1 inch, exit distance is 1 inch. Now these are all numbers that the system has determined based on the size of the tool and the stock size, and so all these numbers should work out. The max step over is set at 1.5, so we have about a ½ inch overlap between passes. We're going to climb cut and we're going to reverse the direction of the last pass. Now we're not going to do anything about auto angle. We're going to go ahead and click OK and see what the toolpaths look like. So click on backplot selected operations. So make sure there's a check mark right here on the folder that we created, and then left click on backplot. We zoom out just a little bit, rolling your center button, and then set your speed to about midway and click on play. So you can see it's got about a 1/2 inch overlap right here on the far side. Then it comes across, it jumps back up, goes back to the other side, and that is because we picked a one way, and then on the last pass it reverses direction, so it doesn't pick back up and goes to the other side, it reverses direction. So you're always climb cutting when you're overlapping an edge, and that pushes the burr to the inside of the material. So you can see 3 passes to face off the 3-inch width, which is actually 3.5 inches because of the excess stock that we have. Alright, now if you would prefer to start on this side and work from front to rear, then the way to make that change is go ahead and click OK to get out of simulation. Left click on parameters, and where it says auto angle, the roughing angle is set at 0, so go ahead and put 180 degrees. Then click OK. Now you can see there's a red mark on the toolpaths, so we need to click on this button that says regenerate all dirty operations. This operation is now dirty because we made a change. So click on that, make sure that red X is gone. You can see the preview of our new toolpaths, backplot, and play. So now you can see it starts on the front side, makes one pass on the front, jumps up, comes back, comes across again, and then reverses direction on the last pass to make sure that we're always climb cutting and pushing the burr to the inside of the part instead of off the edge. Alright, so that takes care of facing. So let's click OK. Alright, next we're going to mill the outside. So we're going to click on the icon to set our construction plane to top. We're going to zoom in and we're going to right click next to the red arrow. We're going to wand over Mill Toolpaths, Contour, and we're going to click right here on Partial and then put a check mark in Weight. Now we're going to walk around this part in a clockwise motion, so we're going to be climb milling around this part. The first leg we want to do is this top leg right here, then this right one, bottom one, and the left one. So once we've got them all highlighted, we click OK, and then this menu opens. Toolpath type is Contour. Tool, we're going to have to select a new tool, so we're going to click on Select Library Tool. It should automatically come up with standard end mills, and if not, click on Filter. Make sure that end mill flat is highlighted, and we can turn these off. Click OK, and then all you should see is flat end mills. Then we're going to pick a 5/8 flat end mill, and we're going to click OK. We're going to right click on that tool and click on Edit. We're going to make that tool number 2. Then click on Parameters. We're going to feed at 20 inches a minute, plunge at 50, and retract 100. And the spindle speed we're going to put at 1500. Then we'll click on Coolant. We'll pull down this menu and click it to On. And click the OK button. And go ahead and click this to Carbide. And then we'll click OK. Alright, so you can see we have a tool diameter of 0.625, 0 on the corner radius. The tool name is 5/8 flat end mill, and we got tool number 2 with length offset 2 and diameter offset 2. Alright, then our feed rate is set at 20 inches a minute. Feet per tooth is roughly 3 thousandths and 3/10ths. Our plunge rate is 50 inches a minute. We got a clockwise spindle direction, which should post out a M3, a spindle speed of 1500 RPM, which is roughly 245 surface feet per minute, and then a retract rate of 100 inches per minute. Now we're going to put a check mark in force tool change and also in rapid retract. That way we're not feeding when we're retracting, but we're rapiding when we're retracting. And then we're going to type in rough outside. Alright, so that takes care of the tool page. Then the next thing I want to do is go to cut parameters. We're going to set compensation type to computer. You can see the options we have. We'll let default out on computer. Compensation direction left, we're going to do line left. and tip compensation set to tip. Roll cutter around corners, we're going to set that to none, and stock to leave on walls, let's put in 20 thousandths. That contour type set to 2D, and that takes care of this tab. Then the only other thing I want to do right now is go to linking parameters, make sure that everything is set to absolute, no check mark in the top, the retract set at 1/4 inch, feed plane to 100 thousandths, top of stock is set at 0, and the depth is going to be -1 inch. Now at this point, let's click OK, and let's do a simulation. Now notice we have a red X in our box, so we're going to have to click on Regenerate All Dirty Operations. Alright, so now look here. This is the tool path, and you can see the lead in. You got a straight and then a arc in. It walks around the part and then it arcs out, and it does that in the middle of the part. So let's watch that tool path. You see it arcs in, it makes a sharp turn, walks all the way around, and then arcs out in the middle. So now what's going to happen in the middle of your part, you're going to have a lead in and a lead out, and that usually shows up as a little ding in the middle of the part. So let's fix that first. Click OK, then left click back on parameters, and then left click on lead in, lead out. So the first thing we're going to do is unclick where it says enter and exit at midpoint in closed contours. So if you do that, click OK, regenerate dirty operations, and now you can see it moved it from the middle to the end of the part. So let's watch our graphics. You can see it arcs in like that, walks all the way around, and arcs back out. Okay, now click OK. We're going to change that just a little bit more. Now right here where it says entry, you have a perpendicular and a tangent option, and we're going to go ahead and leave it at tangent. Then it looks at the diameter of the tool and it automatically puts that 625 thousandths in it. Now we're going to leave that alone. Now here where it says arc, we're going to go ahead and make that 0. And then notice in the middle we have this double arrow. We're going to click on that, and what it's basically going to do is copy our numbers from left to right. And these are the values for the exit. So at this point we click OK. Again, we need to regenerate dirty. And now watch our toolpath. Now remember, these are rough passes. Okay, so now we are directly in line with our first piece of geometry. Just going to walk all the way around. And you can see it stops beyond the excess of the part. It started right here beyond the excess of the part, and it ended beyond the excess of the part. So that's good. Alright, so far we've looked at this from the top view. If you hold your center button down and you roll your model, you can see that the tool path is basically located dead even with the bottom of the part. Let's go ahead and click on previous stop. Then we're going to simulate it again. First you see it coming down in Z, and then it just makes one pass, removing all that stock, all with one pass. And that is something we're going to have to work on next. So let's click OK. Go back into parameters. The first thing we're going to do is click on depth cuts. We're going to put a check mark next to depth cuts, and that makes that feature active. Okay, so the max rough step, we're going to go ahead and put in 1/2 inch. Alright, so that's the only thing I'm going to change. Click OK, and let's see how that changes our toolpath. So we click regenerate, and then we backplot again. So now the first pass, you can see right here in the bottom left hand corner we are at -0.5, and then it takes a second pass at -1 inch. So now we have broken up those two passes to make it a little bit easier on the cutter. Alright, so the next thing we're going to do, instead of taking the full width of the excess material, which the end mill could probably handle it, but let's say that you wanted to break up that excess stock, create multiple passes on top of depth of cuts. So click OK. Again, click on parameters, click on multipasses, make it active by putting a check mark in there. And then we're going to make 2 rough passes, and we're going to do 150 thousandths per pass. So just by doing that, we're going to click OK. We're going to regenerate. And now I'm going to go back to the top view, backplot. Alright, let's click play. You can see it stays away 150 thousandths on our first half-inch depth cut. Then at half-inch depth cut it goes all the way to our 20 thousandths plus. Then it goes to full depth, stays away 150 thousandths from our 20 thousandths excess, and then to full depth all the way to 20 thousandths excess. So if we roll our model, you can see it not only takes 2 passes on the depth, but it also takes 2 passes on the outside. So that's how you control those features. Alright, so then let's add a finish pass. Let's click OK on backplot. Now, right here, the folder that is highlighted for the rough outside operation, let's right click and hold your right mouse button down. Then drag it next to the red arrow and let go of that right mouse button. Then we're going to copy after. So now it copied that operation, and then we'll go ahead and move our cursor down to the bottom. You can see you can manage that cursor just by hitting these buttons right here. Okay? So now this is an exact copy of what we just did. So we can change that by going into the parameters, and we're going to click on Tool. We're going to right click in this window and we're going to click Tool Manager. Then we're going to select tool number 2, right click and click Copy Tool. Then right click again and we're going to paste the tool. Then it will give you a warning. It's saying a similar tool, tool number 2, already exists in the tool list. Do you want to add another? We click Yes. Then on the tool that doesn't have a check mark next to it, we're going to select it, right click and edit. And we're going to make that tool number 3, which is going to be our finishing tool. Then click on parameters, and right next to tool name, we type FIN for finish. And we click OK. So now we have a 3rd tool in our library. So we click OK. So you can see tool diameter 0.625, 0 corner radius, and that's a finish 5/8 flat end mill. And that's tool number 3 with length offset 3 and diameter 3. The feeds and speeds I'm going to keep the same. Comment I'm going to of course change to finish outside instead of rough outside. Alright, so cut parameters we're going to change to wear. We leave everything else the same except for stock to leave on the walls. We're now going to change to 0. Now on depth cuts we're going to deselect depth cuts, and also multipasses we're going to deselect because we're going right to full depth for our finish pass. So the only thing we need to change now is the lead in and lead out. On the rough pass we approached our part tangent, but on a finish pass we want to approach our part perpendicular. And instead of 625 we're just going to do 100 thousandths. Then again we click on the double arrows and we're going to duplicate that to the other side. It's going to also exit doing a perpendicular pass 100 thousandths away from the part. So let's click OK, regenerate all dirty operations, and let's watch our backplot. Let's click play. It makes a perpendicular move, and in the program it will activate a G41 line left cutter compensation. Then it walks all the way around the part at full depth, goes beyond the part, and then makes a perpendicular move away from the part, and at that point the program will actually post out a G40 canceling the line left cutter comp. Alright, so at this point you are ready to post out your program. So let's click OK on the backplot and make sure you click on this button that says select all operations. We want to make sure that all these little folders have a check mark before clicking on G1. And G1 means we're going to post the selected operations. Now when the post processing window comes up, make sure you have a check in the NC file and a check in the edit, and that it says ask and not override, because when you click OK You can actually name the file, and in this case we call it milling. If I hit save and the file already exists, you have the opportunity to say no. So in this case we'll say yes, and then it will go ahead and post out your program. So here's our program. I'm not going to go into the details of it, but you can see at the top of the program it's called milling. It has a date, it has tool number 1, 2 and 3, and then we have facing, rough outside, finish outside, and then an M30 for the end of the program. Alright, so that's a lot of information on controlling toolpaths even on a simple piece of geometry like this. There's more videos to come. Thank you for watching.